I would like to announce our first presenter today, Mr. Ryan Kerr.
Come, Patsy. Whoop. You're dismissed. Thank you very much. One machine can do the work of 50 men. However, no one machine can do the skilled work of one blacksmith. Blacksmithing has been around for millennia. It will continue to be a useful trade past my lifetime. Hello, my name is Ryan Kerr, and this is my Masterworks. In this presentation, I'm going to speak about the important history and technology involved in the blacksmithing process. In my journey from creating my first knife to my last knife, it wasn't easy. Why I chose this topic? I chose this topic for a couple of reasons. First, I wanted to do something that I haven't done before. This way, I wouldn't ruin a hobby that I already had by making it schoolwork. I also needed to do something that could keep my interest for a whole school year, or just about. I decided to go with forging because it combined two things that I am passionate about. The first one being medieval age weaponry, and the second one is working with my hands. Also, I wanted to learn forging because I can use this skill in many ways in my future. I could apply to Parks Canada and work at one of the many forges they have running at the historical sites, such as Fort Langley. Another way I could use this skill in my future is to start my own custom metalworks business. This project has given me great practical experience in this area of work. As part of my Masterworks, I was required to do a paper, so I decided to focus on the elaborate history of forging, all the way from beginning to the present. However, first I want to talk about the anatomy of a knife, forge, and anvil. To start with, the knife. Here is the tang of a knife. This is what attaches to the handle. You can also use it while during forging to help shape the tip of the knife. This is the primary grind angle. This is called a bevel, and this is the secondary bevel. Basically, it goes down like this, and then there's another one that goes down. Also, here's the pommel. This is basically the end of the knife and a guard that protects your hand from slipping. Here's the basic anatomy of a forge. Right here is a fire pot. It holds the burning coals, and this is where you place your metal. You have an air source, like a fan or something that can deliver the air, and the air tube that pushes the air into the hot coals. You have an anvil. You have a horn, which is used to help shape the metal. This can make curves and round things. You have the face. This is just a flat surface that you can basically use to smooth things out or flatten things. You also have the Hardy and Pritchard hole. These are for basically anvil attachments. Things like for a cutting tool or to get a specific hole in a hot piece of metal. To start with, the Bronze Age. In the Bronze Age, there was a grand total of 0 blacksmiths. This is because blacksmith is a term referred to people who smith steel, black metal. In this age, they used a process called casting. In this era, they used bronze, the Bronze Age. Bronze is a mixture of copper and tin. However, it's mostly copper, meaning it is soft and malleable and easy to work with. However, copper doesn't make a good material for tools because of it being soft and weak. So early on, smiths figured out how to combine it with tin to make it a little bit stronger. They would melt the copper and tin to mix them together to get bronze. The liquid bronze would then be poured into a mold. The mold could do a couple of things. Could be a couple of things at this time. It could be a wax replica inside a pile of sand or carved into stone. There are many more ways to mold now. After the metal was poured into the mold, it was left to cool down. Once it was cool enough, it became solid. The mold was removed from the bronze. At this time, there would be little imperfections all over the bronze. They would be filed off until the bronze was smooth and shiny. In casting a bronze blade, a file would be used to sharpen it. However, since bronze is soft metal, it couldn't hold an edge for very long or very easily. It also meant that in use in combat, blades would also become damaged very quickly. In this age, sword makers were limited by what materials were available and knowledge available. The quest for superior blades resulted in the discovery of iron forging technology. The medieval age. In this age, this was the pinnacle age for blacksmiths. They were a very important part of each medieval town. They were the ones that made and fixed the tools for the farmers, made the weapons for and armor for the soldiers, and made the religious items for the church. They were the life of each and every town. They were connected to everything, if not directly, indirectly. Steel became the dominant metal because it could do a couple of things that softer metals, bronze, copper, and gold, couldn't do. Since this metal was stronger, longer and thinner weapons could be made. Before any blade that was long or really heavy, it would snap or bend from the stress and the weight. Now, swords like rapiers and long swords could be made. With this new metal came new armor. Since steel was stronger, it changed the way we made the armor. Plate armor is an assortment of metal plates held together with straps on the body. This is extremely different from the previous armor because it added full body protection. The main weaknesses were the weight of the armor and at the joints where a blade could be forced in. Because of the newer and stronger armor, there was no more need for a shield. This freed up a hand of the fighter, thereby allowing many new weapons to be developed. Finally, the Common Age. Modern forging is obviously very, very different from medieval forging. Nowadays, we have electric machines, welding machines, plasma cutters, more knowledge and technology. We can push the limits of what's possible in blacksmithing. We now have an almost unlimited amount of tools that can make forging faster, easier, and safer. We have things like power hammers, which are machines that hit the hot metal very hard and have different attachments to help forge the metal and save your shoulders from the intense work. We have things like grinders that can help shape the metal and make it shiny. We have other tools like belt sanders that put bevels on knives and shine the metal so it gleams. We know much more about the nature of steel and other metals now. We are masterfully able to mix metals to get exactly what we want. We know how to use the different types of steel to our advantage. Another advantage of modern-day blacksmithing is that you can forge by yourself at the same pace that they did in the medieval ages, only with one person. Back then, you'd have to do it with 4 people, 1 blacksmith and 3 apprentices. Today, we can do this because we have things like power hammers and cutting machines. Nowadays, very few people use swords as actual weapons, since we have moved on from bladed weapons to guns and explosives. In terms of battle, however, swords are still around mostly for use in ceremony and sport. Swords are given to high-ranking officers because they did something brave or heroic. These swords tend to be a whole lot prettier and more expensive since the chances of them being damaged are much slimmer. These are for hanging on your walls or carrying around to show your importance. The swords continue to be a symbol of honor and respect and chivalry. My own symbolic sword, we got a piece of driftwood from a beach, pebbly beach, and I then shaped it into a handle. Now I want to talk about the making of my personal forge. It all started on September 27th, 2017, according to my journal anyway. However, I'm going to start off where it actually starts to get interesting. To start, I need to pick a location. I want a place that was safe, had enough space for me. Also, it needed to have enough ventilation. I decided to use an old shed we had. It has a gravel floor so it wouldn't catch fire, and it had enough ventilation and enough space. Then I started the forge. I decided I wanted to have a coal forge instead of a propane one because coal can get the metal way hotter and is more cost effective. It looks way cooler in my opinion and feels more authentic. For the base of the forge, I used normal red bricks. These bricks are not fire resistant, so I couldn't use them for the fire pot. After this, I couldn't really do anything until I met with Ishan to build the forge. Now the fun really started. I met with Ishan to start building the forge. To start, we cut a piece of metal for the base of the forge, which was just a plate of steel. We used a wheel grinder to cut this out. We then made the tube that would be supplying the air. I got to use a MIG welder to attach pieces of the forge together. After this, we used a drill press to drill the holes in the air tube for the air to flow out. Once that was finished, we got a leaf spring. This would be used for my first knife. We then found a log to put the anvil on. The next step was to put it all together at my house. I'll put the metal plate down on top of the normal red bricks. I then went and laid refractory bricks all around the sides. Refractory bricks are just bricks used in chimneys and fireplaces. Basically, they won't crack or crumble from the heat. I started my forge. I made a small fire and just threw briquettes on. I was really curious if it was getting hot. I chucked in a small piece of aluminum and then continued to completely melt. Then continued to completely melt into this weird mercury-looking substance. I was very excited. I had made my working forge. Now I'd like to take you through the steps of making a blade, the way I have learned. These are the steps that I went through. First, to create any blade, you need to know exactly what type of knife you're making will look like. There are different kinds of knives, and the shape of the blade will be determined by what the knife will be used for. Think about it. You wouldn't want to use a bread knife to efficiently cut through a hunk of raw meat, would you? With this in mind, it helps to sketch it out. What type of tip will it have? Will it curve? How long is it? This is important because it can really show what you're looking for in a blade and can help narrow down to the point of what you're trying to make. I found out that you can get templates from online, but I personally think that the best way to do it is just by yourself. Also, make sure to include the type of tang you want. As I mentioned before, a tang is the piece of metal that sticks out behind the knife and then attaches to the handle of it. It's also useful to hold on during the forging process. Choosing your metal. I personally don't have much of a choice in metal because it's difficult to acquire. However, I am grateful for the metal I do have because it's very nice. There's a lot of different steels out there. They all have different hardness ratings. There's also something called Damascus steel, this stuff right here. This is a combination of two different steels rolled together to make a varied matrix of metal. This makes it very strong and makes a cool pattern appear. It is then dipped in corrosive acid, which eats out one of the steels a small bit. And when it is rolled and taken out of the acid, a pattern emerges from the rolling of the two metals. Making a rough profile. Once you have your design in mind and your metal in hand, it's time to start. There's two paths to go down for making the profile. You can use an old-fashioned method to forge a knife, or you can use a modern approach using power tools to save time and effort. However, it's up to you. With power tools, you could use a plasma cutter or grinders and an assortment of wheels to cut out the shape and profile of the metal. Or, if you decide to go the old-fashioned way, some might say more authentic, you can use a forge to get the profile using different hammers to hit the metal into shape. The process of these is quite similar, and the finishing product is about the same. Perfecting the profile. When you have the profile cut out, it's time to get all the details done. Use a grinder to get rid of any of the scale from the forged blade. Scale is little flakes of metal left over from the heating and cooling process. Perfect the curves of your blade, or the angles. Make sure they're what you want. Use a belt sander to cut smooth, polish the knife. This makes it a clean working surface and gets rid of any grinder marks left over from the first process. Bevels of the knife. As I mentioned before, this is the primary grind, and this is the second grind. You're looking at the knife straight on at this point. Once the profile is done, it's time to put the bevels on the knife. The bevel is the part of the knife that tapers down to the edge of the knife. To begin, use a Sharpie to mark out where your bevels are going to start and are going to end. You can use a bevel jig, which is like a clamp that holds your knife in place for you while you're grinding. Or you can just do it with freehand, just using your hands and eyes to measure it. Either one works. You can also use a forge to make the bevels. You heat the knife and put it at a 30-degree angle. Then hit the knife at an angle, forcing both sides into a point. Just make sure you don't overheat the knife when it starts getting skinny, or else it might break off and crumble. Heat treating. This is an extremely important step of the knife making process. Heat treating the knife will harden the metal so it can hold an edge, and it won't dull after every time you use it. To start, you need to heat treat your knife to up to at least 1,420 Fahrenheit, depending on the steel. It is a good way to test if the blade has reached the right temperature. It becomes non-magnetic. Stick a magnet to the metal when it is hot to see if it has hit the critical temperature. Once at critical temperature, you dunk the blade in some kind of oil. The oil can be motor oil, but I personally used vegetable oil. Historically, blades were quenched in water, but it's better to use oil because it cools it slower, greatly reducing the chance of cracking due to temperature shock. You can tell if the hardening went well if a file glides over the metal and doesn't catch. Basically, you can't file it off because it's so hard. Tempering means heating the blade up again, but this time not as hot and a lot slower. Since your knife has been heat treated, it's very brittle. So brittle, in fact, that it could shatter like glass if it's hit hard enough. The tempering process is gradual and softens the metal, making it slightly elastic, so it's still hard, but it won't shatter like glass once it's cooled. You can use a normal oven or even a toaster oven heated to 430 Fahrenheit. Leave it for an hour in the oven, and then after an hour, take it out. Let it fully cool down. After this, it should be fully tempered, and it should also have a slight hay color to it from the tempering process. The knife guard. Every knife needs to have some sort of a guard. Otherwise, your hand could slip and you would cut yourself. The guard could be integrated into the design of a knife, or it could be added as an extra piece. The best material for a guard, in my opinion, is metal, but wood would work as well. The guard has to be big enough to stop the hand from slipping. However, it can be curvy, curlier, or even squirrel. What I'm trying to say is, have some fun with it. Choosing a handle. There are tons of handles out there, all different materials and sizes. The length and shape of the tang will affect the handle choice. The most basic handle is to put whatever material you've chosen on either side of the knife, like a sandwich. These are called scales. Once you have the type of material you want, I recommend choosing something that's not slippery. It's time to attach. Use epoxy to glue scales to the metal tang. Let the glue dry overnight for the best bond. This is optional, but you can also pin the handle to the knife. For this, you run a metal rods through the metal and the wood, and then glue them in place. The last step is to clean up the knife. Cut away any of the excess glue, sand it down. Sand the knife with a high grit sandpaper to give it a nice and shiny finish. Basically, sand the entire knife. Do any small decorative details you might want to add to the knife, like engravings or a touch mark. A touch mark is a blacksmith's special engraving. The last step is to sharpen your knife. Use a sharpening stone, for this will easily sharpen the blade and make it razor sharp. To finish, I want to talk about the making of my first knife and this whole experience. The next story I'm going to talk about is condensed, but it took over place of a couple weekends. I started my first knife with Ishin on a lunch after a Sunday. Before I started forging, I needed safety equipment, like a respirator, heat-resistant gloves, and eye protection, as you can see here. I also specifically didn't wear anything latex or synthetic, because the material catches fire very easily. To start, we heated up the tip of the metal. I started hitting the metal at an angle to form the tip. I ended up hitting it around the horn of the anvil. This resulted with a pointed tip which had a curve. Then I used an angle grinder to cut the tang of the knife. Now I needed to put the bevels on. I used a belt grinder zip-tied to my drill press as a stationary belt grinder, basically something that I could force against and it wouldn't fall over. I put my knife on an angle and started grinding. I had never done this before, so didn't really know what I was doing. I was just going to go for it and figure it out as I was going along. I had an angle starting at 4 centimeters from the bottom of a blade. Looking back now, I should have made the angle of the blade start from higher up. Next, I needed to do a heat treat. I found some vegetable oil in my cupboard and a plastic container. I started my forge and heated up the knife to the right temperature using my magnet. I then continued to stick the red-hot knife into the oil. The container continued to catch fire. Foot-high flames came forth from the container. I was shocked and was suddenly very, very grateful for my choice of wearing gloves. Also, the oil started to instantly boil. The knife cooled down and the plastic container shrunk. However, the heat treat was done. I threw my knife into my toaster oven and began the tempering process. Now I needed a handle for my knife. I decided to use a piece of oak siding for my handle. My dad and I cut the inside of a handle out with the table saw. Then I used wood glue to put the handle together and a merino epoxy to glue the handle to the tang. Once the epoxy was dry, I used my belt grinder to shape the handle as I wanted it. As a final step, I drilled 2 holes through the handle and then pinned 2 bolts in them. Now I needed to cut them off, so I used a grinder. However, when epoxy reaches a certain temperature, it kind of falls apart. So one of my pins fell out from my knife and I had to re-glue it. This is, these are the 2 pins. Finally, I had my knife. When it was drying, gravity took effect. You can see the 2 pins. It was this first one that fell out and I had to reglue. This is the very, very first knife I made. This is just made out of basically rebar, and it was pounded into shape. It's just kind of something to test to see what I could actually forge. My next knife was this. This was just something that I wanted to make. I wanted to get better at making knives, so I decided to challenge myself. I put a curve into the knife. This was very interesting because it was hard to bevel it because I had to do this the entire time. Also, for this one, I added a lanyard to the end of the handle. This is my third knife I ever made. This is small, and for this one, it's special because for the bevels, I used my forged. Until then, I'd been using a grinder to put the bevels on the knife. Also, yesterday, I added a handle to it. This is my most recent knife, and the one I am most proud of. This is the sharpest and coolest one looking, in my opinion. It has this a full metal guard, which I haven't done before. It has a weird pommel at the end, and it is surprisingly balanced. Also, this is the one that I was able to use like 400 grit sandpaper on, and that's like very, very fine. So I was able to get this one looking the nicest. From that point on, I made my other knives. To conclude, I have come a very long way during this process, with skills and knowledge. At the start, I had no idea what was going to come of it, and what would emerge. I didn't know I was going to make a working forge. I didn't know I was going to make all these different knives and discover so much. I've created a forge and learned how to use it to make something cool. I'm very glad I picked this topic. However, there are a lot of people that helped me along this way. I'd like to thank my advisor, Bev, for being a helping hand with everything throughout this whole process. I'd like to thank my external advisor, Ishan, to help me get my forge going and make my first knife. I'd also like to thank my other external advisor, Chelsea, for being an amazing source of information throughout this whole time. Also, a huge thanks to all of learning assistants for repeatedly going over my Masterworks and dealing with my running again and again. And last but not least, I'd like to thank my parents for funding this entire project. Thank you all for coming. This has been my Masterworks.